Welcome back to the PCB manufacturing process series. This series breaks down PCB materials, technology, and the entire PCB manufacturing process in bite-sized chunks with each stage explained in depth. Today's topic is choosing substrate materials. This is the Xiaomi SU7, and this is the SU7's main control board. On a tiny board, essential electronic components are installed. You could say that the heart of every electronic product relies on this magical board, the PCB printed circuit board. Its base material is called a substrate, professionally known as copper-clad laminate. Copper foils are on both sides, with a special adhesive layer in the middle. Just like a sandwich, electronic components generate heat during operation, so PCBs must be flame retardant, from FR1 to FR5. The higher the grade, the better the fire resistance. The most commonly used grade is FR4 epoxy fiberglass laminate. The middle semi-cured sheet is made by drying fiberglass cloth to B-stage, then combining it with epoxy resin, like putting a bulletproof vest on the board, allowing the PCB to survive drilling and cutting processes. When selecting substrates, pay attention to the TG value. The glass transition temperature withstands up to 140 degrees C, but after resin modification, it can soar up to 200 degrees C. However, the higher the TG value, the more brittle the material becomes. Of course, heat resistance also improves, but so does the cost. How much heat resistance does your product need? What if the TG value is too low? During reflow soldering, the board could delaminate or warp. Besides TG value, another critical indicator is CTE, the coefficient of thermal expansion. This concerns whether the material can resist deformation caused by temperature changes, thus preventing delamination. CTE is divided into alpha 1 and alpha 2. Alpha 1 is the thermal expansion below the TG point, and alpha 2 is above the TG point. Typically, PCB materials have a TG value no more than 170 degrees C, far lower than the melting point of SAC 305 lead-free solder, and the peak ray flow temperature of 250 degrees C. Thus, alpha to CTE becomes especially critical. Moreover, the larger the PCB size, the more likely it is to warp during reflow soldering. To prevent warping, we can enhance the CTE index by modifying the resin in the laminate, or by reducing the resin content. However, this may affect the electrical insulation and chemical properties of the laminate. Next, dielectric constant or decay. The higher end the product, the denser the PCB routing. At high signal frequencies, crosstalk between traces occurs, affecting signal quality. Therefore, choosing low decay laminates ensures better high-speed transmission. Meanwhile, FR4 also has moisture resistance and chemical corrosion resistance capabilities. This is crucial during the PCB etching process. Moreover, different board thicknesses apply to different scenarios. Feel free to screenshot this chart for reference. Finally, regarding laminate brands, besides standard FR4, better choices include Kingboard and Shenji. The difference is that Shenji's products have better thermal, electrical, and mechanical performance. That concludes today's session on choosing substrate materials for PCBs. Thank you for watching. Stay tuned for more in-depth content about PCBs. See you next time.